Hello and welcome to this video. In this video, we are going to study a very interesting sorting algorithm from the algorithmic point of view. That is the kind of variations you can have in this sorting algorithm is quite varying, and that's what makes this algorithm interesting, that there is a lot of room for experimentation and innovation in this. So this is known as shell sort. Fundamentally, it is basically insertion sort. Okay. So our let's go a bit about the programs. Our main .c is same like previous programs. There is not much change. We are back to siren_t. We don't need to use int again like we did in quicksort. We have the same header file, and we to new users we follow this structure so that we can later on call this as a library, and this is the shell sort. So what we do in insertion sort, if you remember, is that the element moves one by one. Okay, so it's a slow process, and to speed that up we use the swap of large gaps in shell sort. So the whole idea is that you are able to move multiple positions quickly. So this is the code, and it is fundamentally you pick a gap, and then with that gap you perform the insertion sort. That's it. There is not much in this algorithm. Let's compile and run this program to see whether it works. So I have already compiled it, and I have already run it, so it does sort it. The interesting part is the algorithm analysis, and by the way, this algorithm is given by Donald L. Shell in 1959. That is. So Donald Knuth's book, Volume 3, gives a big treatment to this shell sort method. So just to visualize this, how this works is, for example, suppose this is the original array, and your gap sequences are 8, 4, 2, and 1. Okay? Then 503 will be swapped with 653. That is, the two elements are 8 position apart. So since 653 is greater than 503, they will not exchange positions. But consider 512 and 154. Okay, 512 and 154. So they will exchange positions. So once this is sorted, we will get this array. This is called 8 sorted array. And after the 8 sort, you perform the 4 sort. That is, 503 will be now compared with 612. And 87 will be compared with 170, and 154 with 765, and so on. So once you perform this operation, you will get this, which is 4 sorted. Then you do 2 sort, and then you do 1 sort. So after doing the 1 sort, the entire array would be sorted. So this is the huge discussion on shell sort, on how to pick the gap sequences and the complexity which you get associated with those gap sequences. It's quite a big discussion. Also, if you talk about complexity in shell sort, it depends on how you choose the gap sequence. For example, we have chosen 1, 2, 4, 8, and so on. So this is n by 2 to the power k. So this algorithm is n by 2 to the power k. That's what we have chosen. So if we choose that, then our worst case complexity would be theta n square. And similarly, if you choose other gap sequences here from this list, you will have corresponding worst case time complexity. So you see that this is an algorithm where, depending on your gap sequence, okay, that is whether you choose something like n by 2 to the power k or 1, 3, 7, 15, 31, and so on. So depending on your gap sequence, the complexity of algorithm varies. Now, the mathematical treatment of Donald Knuth, if you study this in detail, then you will find the interesting facts which are involved with shell sort. So there is nothing much conceptually apart from picking up gap sequence. So for example, one of the gap sequences, which is this one, it has no general term. Okay, and this is one of the latest techniques. Okay, circa 2001. Now, suppose we take this, okay, and we want to sort this using that. So what we can do is we can flip this code. Let's see if this works with this gap sequence. Okay, and most probably, although its complexity is not known, most probably it will have better complexity. Otherwise, it won't be even mentioned here. So let's compile this. So yes, we see that it sorts the array. Now, what I will implore you to do is that you go to these links and you read the uh, algorithms described in the paper. Okay, so various gap sequences are there. You see the complexity varies a lot in this. Okay, so that's why it is one of the most interesting algorithms, although it is not used. But if you are mathematically inclined, then you'll find this is one of the best sorting algorithms to study from a mathematical point of view. But apart from that, from a programming point of view, it is not very useful because quicksort still beats it, or mergesort, or library sort, or timsort beats shell sort by a huge margin. So with this, I'll just stop here because it's not really a novel algorithm that has very good time complexity, and it does not have a very different algorithm with which we need to discuss because we have already discussed insertion sort. So with this, I'll stop the video here, and if you want, you can read everything which is given in Ronald Knuth's book, and maybe you can read the papers. So I hope you have enjoyed the video, and I'll see you in the next video with counting sort. Thanks a lot for watching. Happy programming. Enjoy.